Perfect. Sorry. Go ahead.
Yeah. So I remember so Professor Romke gave us a little bit of a bio for all the speakers, and then so I was um looking at your LinkedIn, and one of the things I noticed was that you were doing Eng Phys
Yeah.
in Eng Sci, and so I was just curious um it seems like you've now moved towards the software side. How I guess how did you make that transition, and what were some of the main reasons why you decided to transfer from physics to software?
So what major are you doing?
Yeah, so I'm in the machine intelligence major. I think it's a really new major. I think just 2018, 2019 they started.
Yeah.
Um, so yeah, um, currently I'm in my third year, but I actually did my PUI after my second year. So
Okay.
um, I was at NVIDIA for a year last year. So
That's
um,
awesome.
yeah.
Um, so yeah, Enchfizz was one of the first majors that we had in the inside program. And as a kid, physics always interested me. Like I grew up at the time when Feynman was sort of very popular, and you sort of grew up with people referencing his sort of Challenger disaster
Mhm.
moment where he drops the O-ring in ice water and proves that it becomes brittle. And it sort of proves that, as he puts it, it doesn't matter who you are, how smart you are, what your name is. If it disagrees with experiment, you're wrong. And so that was
Mhm.
the appeal of physics. But one of the things that was especially true in my case is I was at University of Toronto as an international student. And so the only path forward at that point for me in physics was to get a PhD and sort of go down that path. And don't get me wrong, that's a
Right.
path that I'm very interested in till this day.
Mhm.
But around the time of my fourth year, I'd already did a little bit of work in photonics, got a paper published, done all that kind of stuff. And I realized that I don't have the temperament to wait 3, 4 years for a result.
Right.
For me, like the maximum I can wait is 6 months, and I need to see something moving.
Right.
And I still remember that summer where we were deriving like the time frequency dynamics of anyway, without getting into details, we were deriving
Mhm.
some equation to model how the physical world worked. And I
Right.
had a lot of fun, but it was basically 3 months to get to one result.
Right. Right.
And even after that result, it was a year to get the paper published.
Hmm.
And that was just so frustrating. So I knew that the odds of me surviving in academia were kind of low.
Right. Right.
Um, and so then I started looking into what are some of the other things that I'm interested in. And I applied, like, it was very much spray and pray, right?
Hmm.
It was applying to finance jobs, it was applying to comp sci jobs. Anything that I was sort of remotely interested in, I gave it a shot.
Hmm.
And I got a couple of callbacks. Banks were interested. At that time, interestingly enough, I don't know what exactly this signifies, but that was one of the years that Amazon came to campus to interview people. And
Oh.
I think it was also one of the last times. So I was, I think, the last batch. But at that time, what I realized was I had always grown up with tech. Tech was like second nature. I was that kid who would go play around with routers. One of my first intern projects in the Kuwait Institute of Scientific Research was setting up a Beowulf cluster. Little things like this. And coding is just like a natural part of physics these days.
Hmm.
Computational physics is how you validate your theoretical ideas. And so coding was definitely something I was interested in. Technology was something I was interested in. So computer science and software in general seemed like a very good fit.
Right.
And when I went into the interviews, I actually had exactly one day of prep. for the
Oh
Amazon
wow.
interview. I still remember because I got a call back and I didn't check my email. And then they told me that, hey, you have an interview on this and this date. And I checked it like a week later and I'm like, shit, that's tomorrow.
Oh no.
Um, but that's where the physics background helps. Like a lot of computational physics, you know data structures, algorithms, you know the basics and foundational parts of computer science.
Mhm.
And that's kind of all they're looking for when you're applying for an entry level position, right? It's all of that. How good are you at the mathy part of it?
Right.
How good are you at the problem solving? Because the rest of it, software design, working in large teams, the things that actually make software software as opposed to coding,
Mhm.
all of that you learn on the job. So when I got the offers that I had, and I talked to a couple of people on their day to day jobs and what their day to day looks like and what made them happy at work and what made them sad at work, I realized that software was probably a very good fit.
Right.
You work on projects, especially as you get more senior, you work on projects that have a longer time horizon. So you're looking at like 2 years for a project to be complete.
Mhm.
But like every month, you're seeing some movement. There's like a little bit of the feature that gets built every month. And so it doesn't suffer the same problems as physics. And from a problem solving perspective, there's very little in the way of limitation in software. The
Right.
analogy that I like to use is you're building castles, like sand castles on air. There is no firmament. There is no laws of physics that you really have to adhere to. There's no restrictions. There's no guidelines. You do what you want. If you want to build an app that does something crazy, who's going to stop you?
Mhm.
So in that sort of environment, it is a very create. It can be, sorry, it can be a very creative discipline if you want to make it that way. And so I found that that very much appealed to me. And so that's why I did the transition. And the base level skills I had from physics,
Mhm.
it was just, I think, the working together in a corporate environment that I had to learn.
Right. Yeah, I think you mentioned an interesting thing about like the contrast between like research and like software development because I guess like I haven't really given you much of my background, but like I mentioned that I'm doing like machine intelligence, and
Okay.
so um for the past several years I've been like doing research at a lab
Okay.
at like a robotics lab. So I've been like and so like I and then like I spent like a year at NVIDIA where half of it was like I was doing like normal software engineering work for their like robotic simulators, and then the other half I was like doing like a research project
Yeah.
there. So like I noticed like the very similar thing where like research was like very like punctuated. Like you'll have like sometimes just like months of like dry spells where you're just trying things on the cluster and like nothing is working, and then like one night something just like the stars align, and then like
Exactly.
like you get the result that you need. And like don't get me wrong, like that was like it's a really good feeling when that the stars do align, but like with the uh engineering part, it's like every day in the stand-up meetings, you know, you're presenting your work and you're seeing the progress slowly get made. And um like for me, like we just started, like I joined just as like a new feature was like a new product was being created, so I was there from
Greenfield.
like the
Yeah.
ground up. And then like being there for like 12 months, at the end of the 12 months I would see like how far the product has come. And like more gradual and steady progression is like it was something that I really like missed from research, because it is like really satisfying to see, like, you know, like as you said, like a new feature, like all of that. So
And I
yeah,
think
I think that's pretty interesting.
another important thing, this is more advice. I didn't have this when was starting out, but one of the things
Mhm,
that I realized was there's a very clear skill tree, if you will, to use a video game analogy,
mhm,
when you're working in industry as opposed to research. Because you start off in industry, someone tells you exactly what to do. And then you sort of up level to someone telling you, I want you to build this feature. This is how it should interact with the world, but you figure out the internals. And that's sort of when you're an intermediate. And then when you get to a senior software developer, it's sort of like, great. We have this team of like 12 people that are working together. Let's figure out, and we know we want to build this thing. Let's figure out how to build it. So you're helping figure out what work these 12 people are going to do. And then when
Hmm.
you get to staff, it's like, okay, let's figure out together what exactly it is that we need to build and what is the right integration mechanism. And a lot of this is sort of that skill progression. You have very clear checkpointers to say
Hmm.
that, yeah, you're doing good. Because when you're starting off, you build the thing, it works. You build the
Hmm.
feature, it works. Then your team successfully builds a project that launches and has good return. And then all of a sudden, you're figuring out what a reasonable thing is. And at every point, you're getting lots of feedback, right? Are you doing it on time? Is it under cost? Are you estimating correctly? Did you make the right assumptions? Because at some point, you have to face reality. And because you're doing that so often, you get a lot of that feedback. So it becomes what was that book? There's that book by called Flow by Sarnecki, where he
Oh,
talks
I think I've
about
heard. Right.
fantastic book. Recommend you read it. But he
Hmm.
talks about like evil environments versus supportive environments for learning and how you can hit that flow state. And that constant feedback is that very supportive environment. And
Hmm.
if you get it wrong, unless you're working on something like HIPAA or medical, what's the impact? Amazon goes down, people can't shop, right?
Hmm.
Yes, I get that it's bad and there's revenue impact from like a corporate perspective, but from like an ethical perspective, there's nothing that really goes wrong. So you don't
Right.
wake up going like, "Oh my God, what did I do?" You just wake up going, "Yeah, let's not do that again." And so it becomes this very sort of virtuous environment for learning. So that's another big difference,
Right.
which I found very important for me.
Right. Yeah. And I think I noticed like one thing with like Einstein in particular is that like it's always like a lot of like you're doing like a lot of courses and it's like a lot of work and like it feels like over the years, like the most important thing was like not like any specific thing I've learned in a course, but more so like learning to deal with all the courses and learning to like learn, I guess. Because like that's sort of been like the biggest like takeaway for me at least in like exercise, like I guess like trying to like figure out like uh I still have one more year, but like it just like trying to fit like being on my feet and being like given a bunch of new concepts and stuff and trying to figure out like how to like learn it really has been like I think like the biggest like takeaway that I've had from this program, as opposed to like any specific technical skill. Um,
And
yeah.
unless you're working in academia or something super specialized, a lot of what you learn in university is completely pointless, to be fully honest, right?
Oh, right.
Um, if I were working in physics, that's great, but even when I was working in photonics, general relativity wasn't really important. So if I choose to specialize in that area, a lot of the physics I learned probably won't matter. And
Mhm.
if you knew exactly what you're going to do, you could probably learn what you needed to in a year. But it's exactly what you said. It's that stress management part. That is what I think differentiated a lot of like the engineering students versus NSci students is just that as a part of NSci or really any other high stress engineering program, you have to ruthlessly prioritize. And there's those nights where you have to pull an all-nighter because you have like four homework assignments and you're like, no, you know what? I'm gonna get a zero on these two because it doesn't
Mhm.
really matter and I'm already doing well enough and I'm gonna focus on these two. Like that sort of calculus gets
Mhm.
ingrained in you through NSci.
Right.
And it's so useful when you go to industry or even when you go to research. I have a couple of friends who are doing astrophysics research, prioritizing exactly what they want to work on and what's
Mhm.
most important at any one point, and not getting into that sunk cost fallacy has helped them so
Right.
much. So yeah, you're definitely right. It's prioritizing, handling all of those courses. That's super critical.
Mhm. And sorry, I have a bit of a call.
No
Um,
worries. I'm in the same boat.
um, yeah. So one of the other questions I was curious about was I guess like if you could go back and like give give yourself advice on like I guess like what you would like maybe do differently in Einstein. I know obviously like, you had a bit of like you had like a change in career paths, so maybe what you were thinking of doing in Einstein is not what you were doing now. But other than like let's say like telling the past self like oh like you should probably like consider software earlier. Is there something that you would tell yourself maybe like in terms of how you were like balancing school with personal projects or like uh in general like how you would like want to like change your like would there be anything that you'd like recommend, I guess?
So the first thing is, I would not have told my younger self to focus on software earlier.
Oh, okay.
Physics and really engineering in general give you a very multidisciplinary approach, which is something that I loved,
Hmm.
right? Like biomimetics is something I'm still very interested in. And I would never have even heard of it if not for Praxis. Um, and yes, Praxis, I thought at the time was totally useless, but it's actually the one course that has industry applications. Um, I'm not kidding. I used to bitch to Foster all the time when he was still there that I did not like Praxis, but legitimately very useful. So I don't think I would have changed that. I think there's this interesting quote. I think it was Feynman, but I'm not quite sure, where he's like, when you go to university, you might have been the smartest kid in your class, but you're probably going to end up being somewhat average. And so you need to figure out either you get okay with that, or you build a toolbox that no one else has, that is so unique that the problems that you can solve, no one else ever can. And that's where going through Ensci physics and then going into computing,
Hmm.
I have a toolbox that most people probably never get. And
Oh, right.
that allows me to approach problems differently, right? Formal software verification exists, but the last time someone ran a simulation in software is ages ago. But if you do physics, it's like the first thing you think of. Let's simulate this. Let's see what happens. So all of those sort of tools that you learn and applying them in different places, very valuable. So I would not have thought to get into comp sci earlier or software
Mhm.
earlier. What I think I would have done is I took university very chill. Like I think I went to 10% of the classes I was supposed to go to. Um, I think I should have gone to maybe more classes. That's one of the things that I think back on, and I'm like, you know what? Maybe it would have been nice to go experience more of the university and maybe participate in a couple of extracurricular stuff. I did NSOC and I did that kind of thing,
Mhm.
but I did blue sky racing for an entire summer and
Right.
I couldn't manage it after, right? There's just too much going on. I didn't find time. So
Mhm.
I think that's something that I would have changed.
Right. Oh, okay.
Trying to
Interesting.
find more of a balance where you go to more class, so you have to do less work outside by yourself.
Hmm.
And in return, the time that gets freed up, you could probably maybe do instead of three clubs, I could have done maybe six. Um,
Right. Right.
so it's that sort of thing. I also think I took university pretty seriously. I probably shouldn't have. Because university is that time when you're having fun. Looking back, a lot of people say it was the best time of their lives. You're in close quarters with all of your friends, the people that you see day to day. You get to know them really well.
Mhm.
Probably should have spent more time hanging out with friends and doing fun stuff than actually focusing on university and grades and all of that. So that's maybe a piece of advice I would have given my younger self. But yeah, apart from that, I think university actually was really, really fun. I don't think I would have changed much.
Yeah, I think touching on your last point, I guess I'll stop telling my friends I can't go because I have to study for a midterm.
I will say this. I was very much the pull an all-nighter before an exam.
Oh, I see.
And I personally think that was the right approach. I know people are going to tell you, like, don't do it, it's horrible. But I would
Right.
rather be super stressed for one day
Hmm.
than be stressed throughout like an entire week.
Right, right.
So if you can pull it off, yeah, go hang out with your friends and don't worry too much.
Fair enough.
Yeah.
Um, I think this actually brings me to actually another interesting question that you remind me of, which is like, um, now that like let's say like you're in like upper year, you can like take more electives and stuff, and there's always this like uh discussion I have amongst my friends, like, should I take more like practical, let's say like software engineering related courses or things of that nature, or should I do, let's say, more like mathematical or like just like theoretical courses that probably I won't use ever in my like uh day-to-day job. It seems like from at least the discussions with you that you would encourage to do the more like if I'm in like, if you're more interested to do the more like I guess like theoretical ones that aren't necessarily related because it builds like that toolbox for you.
That is definitely one part of it, but I'm also a big advocate of learning for the sake of learning. Like I still do courses. I use Coursera a fair bit. I use
Mm,
Udemy. It doesn't matter what it is. I like learning about things. And I think that's a very important mindset to have. And one of the issues that I take with people focusing on things that are too practical is they solely lose their love for learning. And that sort of kills you long term, right? Because if you don't want or if you don't enjoy learning, then you're going to stop learning the moment you have to, or the moment you can,
right.
rather. Um, and till this day, like I still spend a day a week going through articles and blog posts and trying to learn something new. And I think that really helps because it compounds, learning compounds over time. But leaving that aside, yeah, build that toolbox, do those weird things. Like I took a course in nuclear engineering. I was an
Oh
international
wow.
student. There is no chance in hell I could have worked at any nuclear facility. I just did not, I would never have gotten the security clearance. And so from that perspective, it is completely pointless. But I was always curious, like how do people build nuclear reactors in a way that, it can shut off safely and what are some of the control mechanisms in place to prevent like um let's say horrible things from happening. And so that was one of those classes that I really enjoyed. So yes, build that toolbox. Don't worry too much about the exact specifics
Mhm,
of is this going to be useful or not? Because the honest truth is, even at like the master's level, I went to Waterloo for all of 3 months to see if I was interested in comp sci. And as a part of that, I was grading like graduate student coding assignments, undergrad coding assignments.
mhm.
The code quality was not great, right? What they teach you in university really is not directly applicable. What you really care about are the basics. You want to know your data structures well, you want to know your algorithms well, but beyond that, advanced graphs, right? Unless you're building a graph database,
Mhm.
you're not going to care. And if you're just joining a company, even if you're working in ML, when are you going to build a graph database?
Right. Yeah.
Right? So don't worry about it being practical coding heavy or whatnot. Just
Mhm.
have fun, learn some weird things, make sure your fundamentals are good. And then
Right.
when you
Right.
get into industry, the thing that's actually going to pay off is finding a mentor,
Mm.
right? There's this interesting idea called the Dreyfus model of knowledge acquisition. And it talks about who you should be paired with in order to facilitate learning. And one of the things there is you want to find a mentor who's maybe 2, 3 years further along your path than you are. Because
Mhm.
they're not that far along that they've forgotten what it's like to be, right? Um, but they're also far enough ahead to give you useful advice. And so you want to find that mentor and they can help you like make sure your coding is up to snuff, make sure the quality of your output, you're thinking about testing all of those things the right way.
Mhm.
And that matters so much more than most things you learn in university. Now, that's not to say all courses in university are bad. There are some that are really, really useful,
Mhm.
but those are more the open-ended problem solving ones because that's actually what you're going to be doing day to day. Any specific course, unless you know for sure that, hey, I want to go do this,
Mhm.
not going to be useful. And if you know that, then you wouldn't be asking me the question.
Yeah, yeah. I think, like, uh, it's like it's really interesting the way you put it, but it's also like pretty reassuring as well because you don't have to like because in other it makes it seem like I don't have to stress about like um doing trying to make sure I get into like all the courses that I want to because at the end of the day it's just about um learning something interesting. Because I remember I think like for this year I was like really trying to get into like this one like machine learning course and I couldn't get into it. So now like I was doing control theory, which
Yeah.
is like completely different from anything I really do. And so at first I was like, oh man, like what like like what's happening? Like this is just like not gonna be practical. But like it's been a pretty interesting experience because it's a way of thinking that I would not have like thought of before, like looking at like system identification and stuff. And so I like it's been a really good learning experience, actually.
And that's, I think, important because systems thinking is one of those things where it pays off big time because it factors a lot into organizational design and even program design.
Hmm.
And the funny thing is, like when you join as, let's say, a software engineer or an ML engineer, you're actually doing the job. You're
Hmm.
building models, writing software. And that
Right.
holds for about 3, 4 years. And then when you get, like, I still remember when I was a senior engineer, I didn't write much code. Like maybe one day a week was towards writing software.
Hmm.
A lot of it was about reducing ambiguity, helping other people solve things. It was acting as that force multiplier.
Right.
And then the further up you go, the more that holds true.
Hmm.
And so the interesting thing is all of that ancillary knowledge that you think isn't important because it's not related to the job is only true if you intend on always writing code. But the average person is like, okay, how do I expand my scope? How do I expand my influence? Because I don't know about you, but what really matters to me is that I am building a product
Hmm.
that I care about. I don't care if I'm writing code. I don't care if I'm talking to users. I care about solving the problem for people.
Hmm.
And with that sort of mindset, as you progress, you start writing less and less code. And like the honest truth is, I was talking to a principal engineer at Amazon, and they were like, I had to find time to write code just to make sure I didn't forget to code or forget how to code. Because a lot of your time is just spent helping everyone else and acting as that leader for everyone else. So, yeah, like systems thinking is going to be super useful when you hit that stage in your career.
Hmm.
But really, anything weird, anything that's unique will find some applicability at least once or twice. So, yeah, don't stress too much about it. You'll figure it out. There's not a lot that is very specific that university teaches you. So, yeah. And if you really wanted to do a course and you couldn't, that's fine. Like the World Wide Web is a thing. Pretty much all the information
Yeah.
you want is online. So you'll find time to learn what it is you need to learn.
Hmm.
So I really wouldn't worry about it.
Yeah. Oh well, yeah, um yeah. I think like it's one thing like when you hear like your professors say like, oh, like this is gonna be super useful, and you're just like, okay, yeah, sure. Like, yeah, of course you want to sell me that this is gonna be useful, but it's a completely different thing when like, like you talk to someone who's actually like working in industry and like like talks about how this is actually like useful. So it has been a pretty interesting learning experience right now.
No, for sure. Uh, A lot of it is sales. You're right. A lot of professors are going to tell you that, hey, semiconductor physics going to be super useful. And it's like, yeah, if I work in semiconductor physics, I'm sure it is. Um, but yeah, general systems thinking, anything that is broad
Right.
is typically very, very useful.
Yeah, interesting. Um, yeah. I think like these were all the like um questions I really had. Like I didn't really have any like I think most of my questions were really just about like yeah like uh like more like big picture. How do you like how you navigate through how did you like navigate through Einstein like your last 3 years of Einstein before going in and it's been like it's been really illuminating really Um,
For sure.
it's yeah, it's it's been really cool to just hear about uh like how like learning about different things is like really helps for your problem solving. So yeah.
The one thing that I would say is the important thing about Ensci is the community you build along the way. Someone once told me, this was someone who was mentoring me and helping me out at work. A big difference between a junior and a senior engineer is the senior engineer knows when to ask for help. And I think
Mhm,
that applies at pretty much any stage, right? Don't feel like you need to solve everything yourself. I know Ensci is very independent and people are doing things, but at least in our year, like people were sitting together doing study groups and trying to solve problems together. I still remember we had Stangeby and I don't know
mhm.
if you still have him. Is he still
Oh
the
yeah,
top?
no, yeah, he's still around.
Is his final exam still as crazy as it was when it was okay?
Yep.
So it was when he was doing those sort of problem sets and those assignments, and the questions made no sense compared to what we were doing in class. I still remember sitting together as a group trying to figure this stuff out. And it's that community that you build, and
Right.
rather that skill at building community that you really care about. I think from inside, that has really paid off for me. Because no matter where
Mhm.
you go, you want to build that community. Um,
Right.
you want that community at work where you're working with interns or other engineers trying to solve problems, asking for help, and
Mhm.
making sure that you help people in return. Um, so yeah, focus
Yeah,
on that
it's
number
funny
two.
you mentioned that because like in my like probably like first like 4 months of my internship, like
Yeah,
I was just like so scared to ask on like the Slack channel, like for any help on like errors that I was having or anything. And I was just like trying to comb through the whole thing. And then like I would just like my like mentor would be like, just ask this on the Slack channel. I'd ask it, and then within 2 seconds, I'd
yeah.
figure out the issue. And I was like, I wasted a day just like so scared of asking when I could have just like gotten rid of this in 2 seconds.
Honestly, that's where I think the Stack Overflow model is great. If you want to ask for help, you write down all of the things you've tried, and
Mm-hmm.
then you post that question on the Slack thread, doesn't matter where, and then yeah, someone will help. As long as you're not wasting someone's time. People are
Right.
generally very happy to help, right?
Mm-hmm.
And yeah, that experience that you talked about of being scared to ask for help is something that a lot of my interns have brought up as well. So it's not unique to you. And
Yeah.
it's true for most people. Like even someone with like 8 years of experience can be afraid to ask for help because they're now worried, like, hey, I got 8 years of experience. If I ask this question, maybe it looks like I'm really stupid.
Oh, right.
So you get all of these different versions and flavors of that imposter syndrome stuff kicking in.
Mm-hmm.
And yeah, it's learning to ask for help the right way, learning to ask for it when you need it, super important skill. So not alone in that.
Oh yeah, I remember like I think like the first couple weeks like I I made like a small like I just like pushed to like the wrong branch accidentally, but then in trying to like fix like go back and fix all my issues, like I was just like panicking, and then like my mentor was asking like, is everything okay? Like you haven't pushed yet, and then like
Yeah.
I'm like creating like three different branches accidentally, and then I like he was really nice about it. He got on call, and then like he showed me specifically what I did wrong, and then like yeah, ever since then I've rebased properly. But like it's yeah, I think like in the moment, especially for like yeah, like for people who just joined like very new, like uh a lot of companies like the internal code base is like completely different, and
Yeah.
like I know like I spend like a big time just like learning like to get to grips with it, and like yeah, it's like sometimes like what you feel is like a dumb question. Like I remember like some of the engineers were like, no, this is something that like we just haven't documented, and it's like just like tribal knowledge that like only like the few internal engineers who work on this feature really know about. But like so yeah, it definitely I learned to ask more questions and not feel too like stupid to ask.
I think another thing that's really important to remember when asking questions is sometimes your questions illuminate bad design decisions almost.
Right.
In the sense that if an intern comes in and they complain it takes 1 minute to build,
Mhm.
Someone's going to be like, well, it took 10 minutes. We brought it down to one. And they're going to be very proud of that. And it's like, well, 1 minute is still too long. There's something wrong about how we're building stuff. Are we caching stuff in the way? Um,
Right.
are we reusing stuff from previous builds where we can? And so all of
Mhm.
those sort of questions come up from like the really simple, straightforward question, right? And
Right.
you start getting into the nested series of whys, right? This was a technique that I don't remember where I heard, but the more whys you ask, the more likely you are to get to something interesting. Like, why is ice slippery?
Mhm.
Or rather, why do you fall when you're on ice? Well, because ice is slippery. Why is ice slippery? Well, it turns out when you stand on top of ice, it compresses ice, and under that compression, it turns to water, and water happens to be slippery. Okay, so now there are two interesting whys. Why does ice, when you compress it, turn to a liquid? And then
Mhm.
why are liquids slippery? And then you start keeping on asking these questions, and then you hit that frontier of research that you don't know about, right?
Right.
Like, why is there even a phase called a liquid, right? Why don't we just go gas to solid? Why do we need liquids in the way? And so you start
Mhm.
asking these questions, and it's the same for software, right? Someone's
Right.
like, oh, why do we have a queue here? Okay, we have a queue here because the process could die in 30 seconds. Okay, why does the process die in 30 seconds? Because we want to enforce some CPU limits. Why do we want to enforce CPU limits? And so the more whys you ask, the more interesting an answer you get. So it's not just for learning, but every once in a while, someone's going to be like, hey, wait a second, you're right. We don't need that queue anymore. We needed it 2 years ago,
Mhm.
but that code has since changed and we no longer need it. That's a
Right.
simplification we can now make. So I think in one sense, asking a question can be thought of as like helping yourself, but
Mhm.
repeatedly building on top of that question can also be really, really good for simplifying architectures and understanding what it is that you're building and really understanding what it is you're building on top of as well. So I don't know. My general philosophy is keep asking questions until someone tells you that you're asking too many questions. And people will
So that's
usually tell you. Yeah,
oh yeah. No, it's been really interesting talking to you. Thank you for taking the time.
for sure. Ritvik.
Yeah.
Yeah, let's keep in touch. And yeah, if
For
you're
sure.
looking at the industry, feel free to hit me up and we'll chat.
Okay, yeah. I'll send you a connection on LinkedIn.
Sounds like a plan.
All right. Thank
Cool.
you.
Take care,
Bye.
Ritvik.
Take
Bye.
care. Bye.